Hello everyone. Last lecture we talked about other two types of cash flow streams, the perpetuities and complex cash flows. So if you were not in class for any reason, you can find the full version notes in the Dropbox folder already. Okay. So in this video, I would love to talk you through the complex cash flows again. So we did not get to finish the whole thing for complex cash flows. So I'm just gonna go over the whole thing again. All right. So, all right. The complex cash flow is any streams of cash flows that is irregular. They can be a mix of positive and negative cash flows, or they can be in different dollar amounts, or they can occur at non-equidistant points in time. So oftentimes they consist of multiple sets of annuities or different cash flow amounts mixed in with annuities. So again, it's just any irregular cash flows. So because complex cash flows are irregular, so we don't have like simplified formulas, and all we're gonna do is just use the principles for complex for streams of cash flows. So we're just gonna jump into the examples directly. So using two examples, I'm going to show you different ways of dealing with complex cash flows. So in example 1, here's the streams of cash flows. So from time 0 to time 3, there's no cash flow. But from time 4 to time 10, each period you receive $500. And the interest rate is 6%. So we have several methods to solve this problem. Using method 1, we can simply use the basic principle, which is that the PV of a stream of cash flow should equal to the sum of the present values of individual cash flows, and the same thing for the future value. So here's what we do to get the PV. So we first find the PV of the first stream of cash flow. Because it occurs at time 4, in order to find the value at time 0, we're going to discount it for 4 periods. Okay, so that's why we have 4 here. And for the second one, we're going to discount it for 5 periods, and for the last one, it's 10 periods. Okay, so it's quite tedious. It takes like 11 steps to get the final number. Not 11, 8 steps to get the last one, final number. Now, for future value, we're going to do the same thing. Find the future value of the first cash flow. It goes from time 4 to time 10. In between, there are 6 periods. So that's how many periods this $500 is going to be earning interest. And for the second one, it's going to be earning interest for 5 periods, and so on and so forth. Okay. Again, it takes another 7 steps to find the final number, which is the future value. Now, in method 2, we're actually going to use a shortcut. Okay. So here's what we're going to do. If you look at, if you observe this complex cash flow in greater details, we can see that actually although from time 0 to time 10 it's a complex cash flow because there's no cash flow from 1 to 3, but during the sub period from time 3 to time 10, it's actually an ordinary annuity, right? So it's equidistant point in time, and each payment is of the same amount. Therefore, we can have a shortcut. So in the first step, we can try to find the present value of the ordinary annuity from time 3 to time 10. Okay, and that will give us the value at the beginning of this ordinary annuity, which is time 3. But eventually, we want to know the value at time 0, so we need to take a second step to further discount the value at time 3 back to time 0. Okay. So that's the basic idea. Now let's see how do we implement it in the financial calculator. So in step 1, to find the present value of the stream of cash flow, the number of periods should be 7 because there are 7 payments, and the interest rate is 6, and the payment is the $500. and FV is 0 because there's no additional cash flow at time 10. So, and we can calculate the PV, which is $2,791.19. This is the value of all those cash flows at time 3. Okay. Now, in the second step, we're going to further discount the value at time 3 back to 0. So the value at time 3 now becomes the future value. Okay. So to get this number in the financial calculator, the number of periods will be 3 because we go from time 3 to 0. Interest rate per period is, again, it's 0, and payment is 0. Okay, because from 3 to 1, there's just one cash flow from 3, right? So in between, there's nothing. So payment is 0, and the FV now is the future value, which is the value at time 3. Okay, and then we compute PV. Okay, that is going to be the present value of this complex cash flow. Okay, so that's the method 2. Now, using method 2, in order to get the future value, we only need to take one step because the end of this sub-period ordinary annuity that goes from time 3 to time 10 is, the end of it is actually time 10. Okay, so if you compute the future value of this ordinary annuity, it's already the value at time 10. Okay, so it corresponds to the future value of this. It corresponds to the end of this whole complex cash flow. So therefore, we only need one step. So again, the number of periods will be 7 because there are 7 payments. And payment is 500, and PV is 0. That's because at time 3, which is the beginning of this ordinary annuity, there's no additional cash flow. Okay, and eventually we compute future value. So it equals to this amount. Okay, now that's the second step. It's a shortcut. Now we have a method 3, which is a specific function in financial calculator that is designed for a complex cash flow. It's called CF function. So the way to use it is that, let's see, if you go to CF function, okay, whenever you go into CF function, you want to clear the memory first. Make sure that all the parameters inside this function is set back to 0. So the way to do this is to click CF and then second, clear work. Okay, now everything inside it is going to be 0. So the way to use CF function is that you're going to tell financial calculator how does your cash flows look like, what's the value at time 0, what's the value at time 1, and so on and so forth. And then you're just going to tell financial calculator your interest rate, and it's going to compute the future value or present value for you. Okay, so instead of doing all those multiple steps, you can get it in one step. So so the first thing you need to, financial calculator wants to know is your CF0, which is the cash flow at time 0. Okay, so obviously it's 0 because there's nothing. Okay, if there's nothing, it's 0. So first one, 0. And now remember, you need to enter. Okay, once you enter, you're going to see the equal sign. And then you go down. It's asking you what's the next cash flow. Okay, so at time 1, the value is again 0. So we're going to go 0, enter. And you go down. Now you see it's F01. It's asking you how many consecutive same amount payments are there. Okay, so, or in this case, it's asking you how many zeros are there consecutively. There are obviously 3 of them, so you're going to go 3, enter. Now, it's asking you, now what's the next one? Okay, so the next one will be 500 because we've already accounted for the previous 4. Okay, so 500, enter. And now you go down. So it's asking you how many 500s are there consecutively. There are 7, so 7, enter. Now you go down. So we've finished inputting all the cash flows. So the next step is to go to NPV. Okay, and I equal to, it's asking you what is the interest rate. So 6, enter. Now it goes down. NPV is what we need to compute. Okay, so we simply hit CPT. So the NPV stands for net present value. It's exactly what we want to look for. Okay, so we get this number in one step. Okay, I'm also showing you all the inputs here. Okay, now in order to find the future value, you're just gonna, if you have a professional financial calculator like this, you're just gonna go further down. Now you see NFV, okay, and you hit compute. Okay, so that is the future value. Not all the financial calculators have the NFV function. So if you have a financial calculator that looks like this, it's a just a basic financial calculator, then you don't have the NFV function. But if you have something that looks like this, that is a professional financial calculator, then you would have the NFV function. Okay. Now, if you do not have the NPV function, you can also get this question done. Okay, but it takes 2 steps. In the first step, you can find the net present value. Okay, so that's something all the financial calculator has. Now, if you don't have an NFV function, then in the second step, you're just gonna take the present value as the present value in time value of money function, and then compute the future value in time value of function in that kind of function. Okay, so let me show you. So we're gonna go back to this third rows. The PV is $2,343.54. Payment is 0, and N is 10. Okay. Why is it 10? Because now the NPV is essentially saying that the value at 0 is 2,343, and then we're replacing all the cash flows with one single number at time 0. Okay, so there's no payment anymore, and then we're just gonna compute the future value at time 10. Okay, so in between there are 10 periods. So 10 N I over Y is the same, 6. Okay, and then we're just gonna compute future value. I'm sorry, it's different. So 6 is 10 is N. I over Y is 6. PV is $2,343.54. 0 payment and compute future value. Okay, so it takes 2 steps to get the same number. Okay, all right. So that's example 1. Now let me show you another example. Okay, so example 2 is very similar to example 1. Okay, so you have the 500s from 4 to 10, but I added another 3 cash flows. Okay, so at time 1 you have 500, time 2 200, and time 3 you have negative 400. So the negative means that it's a reduction in the value of your cash flows. Okay. So to get the present value and future value of this stream of cash flow, we can also take using several methods. The first method is to use just the basic principle, right? So we can find the present value of each cash flow. Okay, the first one, the second one, the third one, and we've learned in the previous example that we can treat the cash flows from 4 to 10 as just one single ordinary annuity. Okay, so we can also find the present value of those, and then we add up everything. Okay, so that is the first method to calculate the present value. Now, of course, you can also use the financial calculator. Okay, let me show you how to do that. So again, you go to CF and clear memory. Second, clear work. The first cash flow is 0, so nothing at time 0, and go down. The first one is 500. Enter, and frequency 1, enter. Next one, 200, enter. And frequency 1. Next one, 400, but it's negative 1. Go down, 500, enter. Remember, there are 7 500s in a row, so the frequency would be 7, enter. Okay, so we've done inputting all the cash flows. Now go to NPV. Interest rate 6, go down. Now we simply compute NPV. Okay, so we have exactly the same number as we have here. Now, in order to get the future value, you can either go, if you have a professional one, you just go down and compute. Okay, if you don't have a professional one, then we're just gonna go back to the time value of money function. So second quit. Okay, so what we know now is that n should be 10. Okay, again, we're replacing all those cash flows with one number at time 0, which is the present value. So from 0 to 10, there are 10 periods. Okay, and go down, I over y 6. PV is 2657.39 PV. Payment is 0. Okay, and compute future value. Okay, so this is the future value of this whole stream of cash flows. All right, now lastly, I want to show you some answers, so how to solve the comprehensive examples that you can find towards the very end of the student version notes. Okay, so here are the questions, and I have all the answers for you here. Okay? Now I'm just gonna go over each one. In the first one, it's asking you how many years it takes for you to pay off a loan of $50,000 at an annual rate of 10% compounded monthly, if every month you pay $600. Okay, so this question is essentially asking you for the payment in amortized loan, right? So we're gonna go second, clear time value of money, and second quit. Okay, so now everything is set back to 0. Because in this question the payments are made monthly, so each period is a month. So n is something we don't know yet. Okay, it's asking you, okay, I'm sorry, it's asking for how many years it takes for you to pay off. So we're asking for n. So that's something we don't know. I over y, each year it's 10%, so every month it's 10 divided by 12. Okay, PV is the amount of the principal, 50,000, and PV, and payment is $600. And remember, the PV and the payment has to be of negative sign, so the payment is negative. Okay, and FV is additional cash flow. Okay, so it's 0. Okay, now we compute compute n. So this is number of months. Okay, so if we want to know how many years, then we need to further divide it by 12. Okay, so it takes 11.9 years to pay off this loan. The second one, we've done this in the lecture, but I'm gonna talk about it again. So if she purchased this new house for $150,000 and she paid $30,000 up front, that means she will borrow $120,000. Now she will pay the rest of the loan over the next 25 years in 25 equal payments at an interest rate of 10%. So what will be the equal payment? So now in this one, we're actually asking for the payment. Okay, so clear the memory. N is number of periods, 25. I over y is interest rate. Okay, so now everything is annually, so there's no conversion. PV is 120,000. Payment, a PV. Payment is something we don't know yet, and FV is additional cash flow towards the end, so 0. Okay, compute PV. So every year she needs to pay $13,220. Okay. The last one, you're given 3 investment alternatives to analyze. So here are how those cash flows look like. So the question is that suppose the interest rate is 6% per year. Can you calculate the PV and FV of each cash flow streams? Okay, so let's start with stream A. Okay, I'm just gonna show you how to use the CF function. Okay, so again we go CF. Second, clear work. Okay, in the first stream of cash flow, we start with, so the first cash flow occurs at the end of year 1. So at the beginning of year 1, that's the time 0, there's no cash flow. So 0, enter. Go down. The first one is 10,000. Enter. And you go down. There are 5 10,000s, so 5, enter. Okay. And from period 6 to 10, those are all zeros. Okay, so you go down, 0, enter, and further go down, so 5 zeros, enter. Okay, so we're done inputting everything. MPV, interest rate is 6, so I forget to put it on the notes, but interest rate is 6. Enter, go down. MPV, we're just gonna compute, so that's the present value, and you further go down, compute, that is the future value. Okay, again, if you don't have a professional one, you can take first calculate the present value and use the time value of money function to find the future value. So that's the first one. Now let's go to the second one. Okay, CF0, obviously it's 0. CO1, at time 1, it's also 0, so 0, enter. How many zeros in a row? There are 4, so 4, enter. CO2 is 10,000. Enter. Go down. There are 6 of them, so 6, enter. Okay. Now MPV. 6 again. Go down, compute. Go down, compute. Okay. So that's the second one. The third one, okay, the first CF0 is the cash flow at the beginning of year 1, so it's 0. Go down. The first one is 10,000. Enter. Okay, next one, frequency 1. The next one is from time 2 to time 5. Those are all zeros. Okay, so 4 zeros. Okay, so the second stream, it would be 0, enter. Frequency 4, enter. Go down. 10,000, enter. Frequency 6 of them. Okay, so we've done inputting. MPV 6, enter. Go down, compute, and go down, compute. Okay, so that is all for chapter 5. All right, thank you. See you in the next class.